We're going to go with a bit of an audible here in the middle of our access list discussion and take a quick look at the network time protocol because it ties into one kind of ACL that we've looked at. And if you haven't seen the time-based ACL video yet, if you skipped that for some reason, don't worry about it. You don't need to see it before you watch this one. But it's one reason that I'm mentioning NTP here. Because in today's networks, it is vital to have the time synchronized across your network devices. Many years ago, it wasn't a disaster because we didn't have all the security issues we have today. People hadn't figured out the vulnerabilities yet, I guess. But now it's not just that we're missing some annoyances. We have to have this done for security purposes. Just a couple of reasons. If your network devices have different times configured, problems from the annoying to the critical can happen. Now, on the annoying level, we have timestamps on log entries. This used to be a pet peeve of mine when people weren't using NTP when they should, because you're looking at timestamps on different routers trying to figure out a problem. You know, you could have three telnet windows open right next to each other, and you got three different routers. You're looking at three different logs, and none of them are synchronized with their times. You know, one of them thinks it's 1993, and it wasn't 1993 then. It's just a bad situation, so it gets very annoying, and it can make your troubleshooting more difficult than it already is or that it has to be. Now, on the more important level, our security services and tools that rely on consistent time across the network won't function correctly. One other thing that pops to mind, of course, secure certificates. That's a big CCNA security topic. If we have certificates inside our own network for devices to prove who they are and servers to prove who they are, well, if they're current, but the device says, you know, if the device connecting to it says, oh, it's 1993, I don't know what this 2013 thing is, you know, they're not going to work correctly. And of course, time-based ACLs, just by the name, if you haven't seen that video yet, they're going to have a pretty hard time of it too. So the typical NTP configuration, I would never tell you there's just one, but a typical config begins with a network device or devices getting their time from a highly believable, secure source. And this is likely going to be your outside router, so to speak, the one that's facing the net, and it can get its time from a secure device. Now, from there, that device that gets the time from an outside source will then give that time to other devices in our network. This doesn't happen automatically. It has to be configured, and we're going to do a baby config with NTP here, and I'll introduce you to a couple of commands, and then we'll have more of that for you in future studies. One other thing we have to be careful about, and I want to mention this, a bit of a CCNA security teaser. Once this router is working as an NTP master clock, you want to make sure that other devices outside your network aren't using it as their time server too, because that's a lot of unnecessary work on your router, and it's not a secure network setup at all. Now, how do we classify all these NTP servers then? We've got some that seem to be more important than others, but we have to have a classification system, and we do with the term stratum. At the top of the NTP hierarchy, we're going to find huge NTP master clocks. I'll show you one in a few minutes here. They're classified with the sinister name Stratum 0. Now, Cisco router literally cannot be configured as a Stratum 0 device. And I've got iOS help here, and I believe on the live equipment as well. You can see the Stratum number is 1 through 15, but you cannot configure it as a Stratum 0. Now, the hierarchy, I want to show you this thanks to a user on Wikipedia. So I really like this illustration. You've got your master time clocks at the top, your atomic clocks, your Stratum zeros. And then you notice we go down in hierarchy 1, 2, 3, and we could go all the way down to 15. And you'll notice, though, that it's not just talking down. You know, the time servers at Stratum 1 aren't just talking down to Stratum 2s. They're also talking to each other. There's some synchronization going on there as well. You can see this with our layer 2 and layer 3 and so forth. Now, if you want to see what a Stratum 0 time server looks like, this is what a Stratum 0 time server looks like. I kid you not. This is from the United States Naval Observatory. It's an alternate master clock at one of their bases in Colorado. This is just a little more powerful than the average Cisco router or even the non-average Cisco router. And again, this is a Stratum 0 clock. So you can see why we can't take our little practice router or something like that and try to make a master clock out of it. It's just a little more complicated than that, and the workload can get pretty heavy pretty fast. So what we can do though, and what we're going to do here is a quick little NTP lab. Just want to show you a couple of commands and one classic gotcha to look out for. And what we're going to do is configure R1 as a time server. We're going to make it the master for this network, because the command can be a little misleading, the NTP server command. And what we've got then is router 3 at 3111 receiving its time from 2111. So let's go ahead and first off make sure we have connectivity, which I'm sure we do, but I'm always saying you need to check it, and there we go. So that's all checked out. And what I've done is set the time on here manually. So now we've got a server. We're going to make it a server, that is. NTP. And what you want to watch out with, you've got NTP server here, and you think, like VTP, it's like, oh, VTP server. But notice what you're doing with the NTP server command is identifying where the server is. You're not saying this device we're on is a server. You're saying, here is the server I want you to get your time from. What we want to do in our network is make router 1 our master clock. So we're going to use the master command to do that. And there's your stratum number, and we'll just pick 5 out of the sky. And that is it. So let's go over to our NTP client. And again, we're going to use the server command here, because notice there is no client command. And we're going to make that 2111. And start verifying. It looks like we're synchronized already. Let's do a show NTP associations. Okay, we are. So it went so fast I don't get to show you the gotcha, but I'm definitely going to tell you about it. The most important thing for you to look for really is clock is synchronized. That's what you've got to have, because if this says clock is unsynchronized, you need to give it some time, because in a larger network that can take more than a few minutes for it to sync up with that device and start getting its time. It's not something that is necessarily going to start working in 10 seconds. Now here we're in a practice lab, we just have a couple of routers and they're right next to each other, no problem there. We had the connectivity and it happened very quickly. You'll notice the stratum here is 6. And what do we configure the other one as? What do we configure our master as? A 5. There's a reference. So the reference, when it mentions this, of course, that is the IP address of the master clock for this particular device. And you can see the time right here, the reference time. We're certainly not going to get into clock offsets, root dispersions, that kind of thing. But I do want you to know that NTP status command and know that the biggie here is to be synchronized. With show NTP associations, and here we go. We see the address of the server or the master clock. There's the stratum that we set of 5. Here's what you want to watch. At first, when you first run show NTP associations, if you just wait about 10 seconds like I did, or even that long, what you've got to watch out for is that you may just see that little squiggle. And see, that means configured, and that's perfectly fine. We know we configured it, we just did it. But the gotcha is that you may not see that asterisk yet, and they may take a few minutes to show up. That means that this is a master and that you are synced up with it. That's what you've got to have. Once you're done with that, once you see synchronized and show NTP status, and you see the asterisk next to this address, then you're gold. You know you're all set. But always give it a little bit of time. In a production network, it could take 15, 20 minutes for it to show up. And if it doesn't show up in 5 minutes, don't start thinking, oh, what's wrong with this config? Because as you can see, it's a pretty simple config. It's just that NTP can take more than a little bit of time to get up and working. There was one more site I actually wanted to show you on this one, and this is ntp.org, the actual home of the network time protocol. And certainly looks like an old-fashioned website, but it's very effective. And you can see that I've already clicked on a link for public time server lists. This is where you actually find out where the public time servers are. Now, that list does change over time, so I don't put any in the books or anything like that. But also, you do want to read their rules of engagement before using these lists. And they've got lists about where the public pool time servers are, the secondary servers, and there's even a list of public NTP primary Stratum 1 time servers. So it's not something that you do without a little bit of planning or even a lot of planning as far as a production network goes, but I did want you to see that website again. It is the Network Time Protocol website, ntp.org. And that is about it, my friends, for NTP. That's a good introduction to it. And in your security studies, we'll get into a little more detail and look at some more different configurations. But right now, on to the next video. See you there.